this problem, we're given the indefinite integral 24t to the 12th minus 10 divided by t with respect to t. Okay, so this is asking us to take the antiderivative of this function and write down what the answer is. So the first thing I want to do with this is split up this fraction, okay, into two pieces. So I'm going to say we have 24t to the 12th divided by t minus 10 over t, and of course this integral is with respect to t. That's our variable. Okay, and then I'm going to split up these into two separate integrals. So the first integral will be 24, and let's reduce this while we're doing that. So t to the 12th, and the t on bottom makes t to the 11th. So 24 t to the 11th dt minus 10 over t dt. Okay, and one more thing that you can do if you want is you can factor out the constants, because the constants aren't going to change anything in this problem, so they're just going to kind of get carried along. So you can factor out the constant multiples there and make this 24 on the outside, and then the integral of t to the 11th dt, and also, whoops, not minus, not equals, it's minus 10, and then 1 over t dt. Okay, so that is within the rules. So now let's go ahead and take the antiderivative. So the antiderivative of t to the 11th power, we add 1 to that power and we divide by what that new exponent is. Add 1 to this one and divide by that new number. So let's keep the 24 out here. Add 1 to the exponent, so the exponent becomes 12, and then we divide by 12. Okay, that takes care of that. And of course, every time that you integrate an indefinite integral, you have to put a c. So I'll put c1 there to say yes, it does have a possible constant. Okay, and then minus, here's the 10, and the antiderivative of 1 over t is ln of t. Okay, but you need to absolute value that. Okay, so it's the ln of the absolute value of t, and then of course that gets a constant as well. Now with these two constants, what people normally do is just wait till the end and put a c, and that's what we will do. So you don't always have to write a c1 and a c2. You could just take the antiderivative here, take the antiderivative here, and then put a c at the end, and that will work as well. Let's clean this answer up a little bit. So 24 on top, 12 on bottom, that's a 2 t to the 12th minus 10 ln absolute value of t plus c. And that's your answer. Let's do one more. Okay, for this problem I have the integral of 5 secant x tangent x plus 2 secant squared x. And we are evaluating this indefinite integral with respect to x. X is our variable. Okay, so we're going to clean this up first, just like we did the last problem. Let's clean this up. So we can bring out the 5, and we can bring out the 2, and we can also make these two separate integrals. So here's my 5 times the integral of secant x tangent x with respect to x, so dx, plus 2 times the integral of secant squared x dx. Okay, now we can take these integrals separately. So the integral of secant tangent is secant. That's the antiderivative of secant tangent. So let's bring down our 5, and we have a secant. Okay, and then we have the 2, and you could put a plus c1 here if you wanted, like we did on our last problem, but this time I'm just going to wait till I get to the end and put a c on the end. So 2 times the integral of secant squared, so secant squared integral is tangent x, that's the antiderivative of secant squared, plus c. All right, and if you ever have any doubts, and this is the answer, if you ever have any doubts about whether you got the answer right, you can always work backwards. What's the derivative of tangent? Secant squared. So the antiderivative of secant squared is tangent. Same with what's the derivative of secant? Secant tangent. So the antiderivative of secant tangent is secant. Okay, and that's it.